3, day 5 notes, and this is Mrs. Sagliano, and we're just going to get started. So basically we are doing function notation, where sometimes you're doing adding, subtracting, multiplying, or dividing. So this first notation represents f of x plus g of x. So you have some expression that's equivalent to f of x and another expression that's equivalent to g of x, and you want to add those two together. The next one is f of x minus g of x. The next one is f of x times g of x. Now it seems pretty obvious that this means addition. This means subtraction. And this means multiplication. So obviously the next one we have is going to be division. It is really important when you get to division that you pay attention to which one of the expressions is on top and which one's on the bottom. So this one is f of x divided by g of x, which you could also write as a fraction if you would like to. So you could write f of x over g of x, which would be the same thing. The next one is composition of function. And I think the important idea about the notation is to look at what this symbol is in between the f and the g. And notice that that's an open dot as opposed to the multiplication closed dot that's filled in and darkened. So this one, the way that you would say it is you would say f of g of x. Now, what exactly does that mean? This is more of a substitution. So the way we do it is you look from right to left. It's backwards of the way that you would normally read. So you would start with g of x and you would substitute it into equation f. All right, and below it, it talks about you take the g function and you substitute it into the f function. All right, now you may see it in either of these two ways. So you could see it as f of g of x with the open dot, or you could see it in parentheses. Now don't confuse that with multiplication. Okay. All right, so now we're going to try a few of these on our own. So notice that they always provide you with the function f of x, it's x squared minus 4, and the function g of x, and that's x minus 2, which could change depending on the problem. So now we're going to look at, well, this says to add. So we want to add together x squared minus 4 plus x minus 2. All right, and then we're just going to combine our like terms. I get x squared plus x minus 6. And that's my final answer. The second problem is f minus g of x. So f of x minus g of x. And we're going to take what was f of x. That was x squared minus 4. And we're going to subtract the entire quantity, x minus 2. Now, I like to use parentheses when I distinguish one function from the next, because this would tell me that I need to distribute the negative sign to everything that comes after it. So then I would do x squared minus 4, but then I'd minus the x and add 2, because I'm subtracting a negative 2. So when I combine my like terms here, I get x squared minus x minus 2. And that's my final answer. All right, the third problem, this one is multiplication. So I'm going to take the binomial x squared minus 4 and then multiply it by the entire binomial x minus 2. So when I do distributive property, I'm going to double distribute, and I'm going to do x squared minus x and x squared minus 2. So that gives me x cubed minus 2x squared minus 4x plus 8. And I'll double check if anything else can be combined, but since nothing is a like term, then I'm done with that. All right, the last one in this problem set is a division. So I'm going to do f of x, which is x squared minus 4 over x minus 2. So from Algebra 2, we remember that when you have a binomial on top and a binomial on the bottom, you can't just divide individual terms. You have to look at, well, is there a way that I could break up the numerator? So the numerator could be factored into x minus 2 times x plus 2. And the denominator could be left the same. But if you notice, we have common terms on the top and the bottom. So since both the numerator and the denominator have x minus 2, they can be canceled out. So if you have something divided by something, that gives you 1, which essentially means that it doesn't change the fraction. So all that remains is x plus 2, and that's in the numerator, so that's all I have. All right. The next one is composition of two functions. So we are going to do g of f of x. So remember, this open circle, that means that we're doing substitution here. Okay. Now, when we do the substitution, we're going to start from the right and work our way to the left. So we are going to take the quantity square root of x, and we're going to substitute it into x squared plus 4. So we want the square root of x to go into this expression, but just replacing the x. So we're going to do the square root of x squared plus 4. And the square root of x squared would be square root of x times square root of x, which is square root of x squared, which is x. All right, and then I'm just going to bring down my 4, and that's it. So my answer is x plus 4. For the next problem, we're going to do f of g of x, which means that I'm starting with g of x this time, taking this quantity g of x and substituting it into just the x in the other function. So I'm going to take x squared plus 4, and I'm going to substitute it into the square root of something, and that square root of something is square root of x squared plus 4. Now, x squared plus 4 is not factorable. If it was x squared minus 4, I could factor it. It'd be x minus 2x plus 2. But since it's not factorable, there's nothing I could do to break this down and simplify it any further. So this would be your final solution. All right, so now they want us to compute a composite value. So they're going to give us two new functions, f of x and g of x. And they want you to find f of g of negative 2. So I'm going to write that out. F of g of negative 2. So there are two ways of doing this. You could first find f of g of x, just like how we did above. So we are going to take the g of x, substitute it into the function f. All right, so we are going to take g of x and substitute it into just the x in that f of x function. So instead of 8 over x plus 5, I have 8 over something plus 5. So what is that something? That something is the quantity x minus 1. All right, but now I need to simplify this a little bit. So if I were to simplify, I would get 8 over x plus 4. All right, and that's my f of g of x. But now they want me to substitute the value negative 2, because it's not just f of g of x, it's f of g of negative 2. So everywhere we see an x, instead of putting an x, we're going to put a negative 2. So 8 over 2, that gives me 4. And that's my final answer. All right, but now we're going to do it another way. So instead of doing the f of g of x substitution first, instead of doing this portion first, right, they want you to now find what is g of negative 2. So really reading right to left, start all the way to the right with the negative 2. What is g of negative 2? Okay, well, g of x is x minus 2. So instead of x minus 2, we have, g of x is x minus 1. So we're going to take negative 2 minus 1, and that gives me negative 3. Then I'm going to take that answer and substitute it into equation f, which equation f says 8 over something plus 5. Well, that something is negative 3. So I have 8 over 2, and 8 over 2 is 4, which is, of course, the same answer we got using the first method. All right, so at this point, we're only concerned with f of g of x, right? So let's look at what is f of g of x. Well, that means to take g of x and substitute it into function f right? Starting from the right, going to the left. So everywhere where we see an x, we're going to replace it with the quantity x plus 3 over x minus 5. All right, so now this is our function. We don't need to simplify it because it would just get messier. And so we're going to look at, well, what would make the denominator 0? Okay, so in our denominator, we have this entire quantity. So this entire quantity cannot equal 0. All right, so now we need to solve for x. All right, if we solve for x, we're going to subtract 3 on both sides. So that's going to give me x plus 3 over x minus 5. That cannot equal negative 3. And then I'm going to multiply both sides by x minus 5. So I'm going to get x plus 3 cannot equal negative 3 times x minus 5. That would give me x plus 3 cannot equal negative 3x plus 15. And if I add 3x both sides, I get 4x cannot equal 12. And x cannot equal 3. All right, so that provides us with an asymptote, right, at x equals 3, because my denominator being 0 would provide where an asymptote would be on my graph. But we also have to recognize that within our function f of g of x, we also looked at just g of x, because we took g of x, which was just this quantity, and anything that's within that domain restriction, right? So if we just looked at x plus 3 over x minus 5, we would have to note that this denominator cannot equal 0. So x minus 5 cannot equal 0, which means that x cannot equal 5. Because if at some portion in my function, even if I'm doing it right here, I would get 2 times 8 divided by 0. I can't do that. All right, but if you notice that it happens in the numerator and denominator, if you have something in the top and bottom, that produces a whole as opposed to an entire asymptote. In any case, the domain has to be restricted, and you can't have 5 or 3, right? Which would mean that we can have any number from negative infinity until 3, right? But not including 3. But then we could go from 3 to 5, and then that doesn't quite look like a 5. I just want to make sure that looks like a 5. And then we can have any number from 5 to positive infinity. Right? So we are skipping 3 and 5, but any other value would be okay. So here's our final answer for our domain. So we're given h of x is equal to 3x minus 1. And we're also given h of k of x is equal to 9x plus 3. So now we have to find what is k of x. All right, so we are going to figure out, well, if we did h of k of x, we know we would need to substitute whatever k of x is into h. So we know we'd have to do 3 times something minus 1, right? Because we're going to take whatever k of x is, put it into x, and that result needs to equal 9x plus 3. All right, so the question is, what needs to go in here in order to make that happen? All right, well, if you look at both sides of the equation, we know we need to get to 9x. So we know we need to have 3 times 3x somehow. So that part is easy. We also know we need to get to a plus 3. But how are we going to do 3 times something? And that could either be plus or minus something. And then subtract 1. How are we going to do that to get 3? Well, I know if I did 4 minus 1, that would give me 3. So how are we going to get that question mark to lead me to a 4? So now you really have to think, okay, well, if I were to do, remember, I'm trying to get 4. So what if I did a fraction? 3 times 4 thirds. Well, 3 times 4 thirds, the denominators would cancel. I would get just 4, and I want a positive 4. Right? All right, so I think I've figured it out. So this is my solution for what is k of x? Well, k of x is equal to 3x plus 4/3. All right, and just as a double check, all right, just to make sure, if I were to distribute this, 3 times 3 is 9, so 9x. 3 times 4 is 12. 12 divided by 3 is 4. Minus 1. 4 minus 1 is, in fact, 3. So 9x plus 3 does equal 9x plus 3. And I think we are all finished, so that is it for today.